Hello everyone. In this video, we are going to learn decision tree regressor, which means we are using decision tree for regression task. For regression task. The idea behind decision tree is it wants each node contains similar numerical values. To measure the spread out of values, decision tree regressor will use variance. What does this mean? Each node contains similar numerical values. Suppose we have values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we split the data at 0.5, the values which are less than 5 will be here and greater than 5 will be here. Similar numerical values means these are close to each other. How they are close to each other? On what basis I am seeing? On the basis of variance. On the basis of variance, we have to find the similar numerical values by using the variance. So in decision tree, there are few formulas we should remember. The first is mean. Is a simple formula, average of your values. 1 by n summation of I is equal to 1 to n into x. That is x1 plus x2 up to xn divided by n, and y bar is mean. This notation we will use for mean, and variance is yi minus y bar whole square divided by n, and weighted variance means variance of left child node and variance of right child node. So we are going to use these three formulas to find the best split for decision tree. Okay, same as we done for the classification task, we were doing for regression task. In classification task, we have used entropy, information gain, Gini impurity plus cart algorithm. But in regression task, we will focus on mean, variance and weighted variance to find the best split. So consider an example of house price prediction based on two features: house size and number of bedrooms. We have to predict house price. See, here the value is not 1 or 2 or yes or no. This is not classification. This is price, continuous variable, continuous values. Regression. So we should use decision tree regressor to find the values. So we will calculate the mean of data set, mean of our target variable first. We will focus on target variable first because we have to find out the variance of entire data set. That is, first is mean is equal to 150 plus 180 plus 200 plus 300 plus 320. I am taking these values divided by 5. I have 5 records. So our mean y bar is equal to 230. Next we will do the variance. Variance is equal to, this is parent, variance of parent, 150 minus 230 square plus 180 minus 230 square plus 200 minus 230 square and so on. Okay, I will do it plus 300 minus 230 square plus 320 minus 230 square whole divided by 5. The variance of parent is equal to 4560. If you make the calculation, the value will be 4560. Okay. So now we will make a split. I'm just selecting randomly. Now we will split the data using the feature house size. Where house size is less than or equal to 1200 square feet. Based on this, I will split the data. If I split the data, see, we got 3 records. That is left node where house size is less than or equal to 1200 square feet. So let's calculate the variance of our left node, left child. The mean y bar is equal to 150 plus 180 plus 200 divided by 3. The y bar will be equal to 176.67. Then variance of left child is equal to 150 minus 176.67 square plus 180 minus 176.67 square plus 200 minus 176.67 square divided by 3. The variance of our left child will be 422.22. This is the value you will get after calculation. Okay. Now I have to do same for the right node where house size is greater than 1200 square feet. What is the mean here? 300 plus 320 divided by 2. That will be 310. And variance of right child is equal to 300 minus 310 square plus 320 minus 310 square divided by 2 will be equal to 100. Variance of right child will be 100. So we have got the variance of right child, and variance of left child is variance of left 422.22. Total records I have 5. Left child has 3. Right child has 2 records. Yeah. Then weighted variance is equal to 3 by 5 into variance of left child, that is 422.22 plus right child 2 by 5 into variance of right child is 100. This gives the weighted variance is equal to 293.33. This is the weighted variance of house size less than or equal to 1200 square feet. When you split the data based on this feature, house size, and this threshold, our weighted variance is this. What was the weighted variance of our parent node? Our parent node variance was 4560, and this is 293. So there is decrease in the variance. So we can consider this as a good split. But we have the other features in data, that is bedrooms. We have to calculate the weighted variance for other features, that is bedroom. Okay, so we have to make further calculation. Machine will make the further calculations. Calculate the machine will machine means our decision tree regressor here. Decision tree regressor will calculate weighted mean, weighted variance of different features with different thresholds. Finally it will find out the feature and threshold which has least variance, and start splitting the data. This is how our decision tree regressor will work. It is different from our classification. Classification, remember, we use entropy plus information gain or Gini plus CART algorithm. But decision tree regressor is based on variance. It is different. It is based on variance. I hope you have understood the decision tree in depth and all the concepts are clear. Please comment if you want, if you have any doubts or something. Thank you so much for watching. Thank you so much.